at pi 2. So before you leave, let me give you your test.
Alrighty.
That.
Yay.
How many of you are leaving at that time? Okay, few of you are. Okay. And now, then some of you have to leave later time, right? Or just 5 to 3. Any other time? Okay. Here we go. Very much.
Yes.
Powell, I need to see you. Really important at the end of the period. Nothing to worry about. But, okay. What is this an equation of?
Circle. A half circle.
Okay. Now, if I would take this half circle and rotate it around the axis here, what would I have?
Sphere.
Okay. What is the volume of the sphere?
4 pi r cubed over 3. Pi r. What?
Okay. Now, what is the radius of that circle?
The what?
Radius of this circle.
5.
Okay. Now, so what would be the volume of this from what you know?
It'd be 600 pi. Oh wait, 200 pi. 200 pi.
This would be 5 times 5, 25 times 5, 125.
Yeah.
And so it turns out to be
500 over 3 pi.
500 over 3 pi. Now, that's what you've been told. Now we're going to do that today using the calculus, and I'm going to rotate this around this axis, and here I'm going to get my discs. You with me? Now we're going to go all the way around here, and we have all these discs, Riemann discs here, and so I'm going to integrate this thing from a -5 to 5, from here all the way to here, and what is the width of this thing? Well, that's going to be a delta x. Now that's a dimension. That's a width. Okay? And some of you blew that on your test. You didn't put these dx's back here. Okay? Very important to have them there. Okay, now what is the surface area of this disk? How do you find the area of a disk or of a circle? Pi r squared. Okay, with you, now listen, what is this height? That's the y height from here to here. That's this thing right here. At this point, x value, that height is going to be this number. And what does this number turn out to be squared? 25 minus x squared, that is already squared now, times pi. Are you with me? That's all there's to it.
Why the pi part?
That's the area.
Oh, okay.
You got it?
Yeah.
Anybody else? Okay, now, I'm going to show something else. Is this an even function? Yes. Okay, so I'm just going to do it this way. It makes life just a tiny bit better. You don't have to do it this way. I'm going to put pi out here too, okay? And so now I have 25 minus x squared dx like this. That's all there is to this whole, in a sense, very complicated idea, but it becomes very easy in the calculus. Okay? So this gives me 2 pi, and now I have here 25
X.
Good, and this becomes
X cubed over 3.
And I'm going to evaluate it from 0 to 5. Okay, so this becomes 2 pi, and then this number becomes 125, right? Minus 125 over 3. Any questions about that? Okay, now this is 3 of those, so this, can you do this fast?
Yeah.
Okay, so there are 2 of the, oh, I better not do that.
250 over 3.
Yes, right. Pi times 250 over 3, which turns out to be 500 pi over 3.
I like the other one.
Okay, This one here is because someone told you, and also Archimedes did a lot of work to get that. Now we can all handle it this way. Okay? Very nicely. So I wanted to show you one application, and this would be a great question for an exam kind of thing. I like it very, very much. Okay? And so makes me a believer in old math, but also in the new stuff, bringing those kind of ideas together. Okay, now next one I'm going to do, I'm going to figure out the volume in a nice little coffee cup, and the cup is going to go like this, and it's going to be y equals x squared, and we'll finish the other side over here, the parabola, and we'll go this high, and I think, what did I do? I went up 4 units here. If that's 4 units, what's this over here? Okay,
2,
got
I
that.
guess.
And we can put an ear on this thing so we know we're getting a cup. And I would like the volume of that thing. Okay? Now, to do that, I'm going to do it over the y-axis, and at this point, I put a delta y here, and immediately back here, I put a dy. That's my delta. Okay, now, this length is an x length. That's this long right here. Okay, so I have to change this to be like this. The square root of y equals x. Are you with me? Okay. Yeah, but we're talking about a positive direction, so it has to be a nice point, but in this case, we throw a minus away. Okay, now, so I'm going to put this here. That's this length, and this is delta y. So, and what do we have to do with it to find the area, the volume, or the area of the disk now?
Right.
This is the thickness, and now I have to get this surface area is squared, right, times pi. Any questions? From 0 to 4. Any questions?
Because you're
From
saying,
here to here.
You're saying square root of y equals rate r then?
Yes. Yeah.
Okay.
Yes.
So pretty much always we're doing the pi's for the circle.
Always.
Okay.
Always. Yep. And okay, now see how nice on this one works. I'll just simplify it a minute like this. I'll put the pi out here. You know we do that. And this is y squared. Oh no, excuse me, just plain y. Uy. That's it.
That would be
Okay. And so what's the antiderivative of that?
Y squared over 2.
Over 2. And I'm going to evaluate that from 0 to 4.
4
8
And-
pi.
Okay. And that's units. Now, okay. Now watch this part. That's units what? Cubed. Derek, this way. This is a length, and that's a length squared. So we have length cubed. We're talking about volume. This is very, very, very important in terms of looking at units. Unfortunately, I can't go into much of the physics this year. If we had a few more weeks, I would give you some more of these applications out of physics, which are very, very interesting to see how the units play. With a question? Okay. Okay. Now, see how now that's the volume inside here. Not bad, huh? Okay. I'd like to do the next one with some discs, and I'll see how it goes. I'll make certain I tend to I stop so I can take care of you. I'm going to do this one. And I think we're going to look at it 2 ways, one going around the x-axis and one on the y-axis. And we'll do that nice little parabola. They work nice. And then I'll go with this line over here like this. And we'll say this line is y equals 2x. And this one going this way is y equals x squared. Okay? Now, what I want to do, the first one, and maybe a little later I'll do the other one, I want to go around the x-axis. With me? So I want to go these like this, and then go around the x-axis, so it goes down the other side too. And come down on this side. So I'm going to wrap this around, and I'm going to figure out the volume of this shaped thing. Okay? What's the volume of it? Okay, so here we go. This is delta x. Okay, so here I go. That's going to be a dx over here. Now, I'm going to run from here to here. What's the value of this point? I'll just tell you.
2.
That's going to be 2 and up going to be a 4. Okay? 2 up 4. So this is going to be a 2 down here. So I'm going to go from 0 to 2. Okay? Now, I'm going to do, this is on the top. Are you listening for that part? This is on the bottom. So this is going to be 2x on the top minus x squared on the bottom. Okay? Now, oopsie, that's not what I want to do. I'll get this out of here. Now I was really start to do something a little bit different there. 0 to 2 is all right. A dx is okay. Now, this is the top side, so I'm going to go 2x and I'm going to square it and times pi. Because this is going all the way around, and I want the total volume out here. And I'm going to cut the inside here, which sometimes we call a washer or like a donut. I'm going to take the middle out. And here I'm taking the middle out. And what I'm taking out is this little part from here to here. That part I'm taking out. Yes?
What kind of shape is this going to make?
Nothing too fancy.
What?
Okay? And so this, now the inside one here is going to be x squared squared. With me?
Y.
Why? Because this length here, like I'm just doing here, is x squared.
Yeah.
And we need the radius squared. That's the radius.
Okay.
And we always square the radius to get area of the circle. Okay, and then we have a pi out here, and I'll just take the pi. There are pi at both places. That's over here. Yes.
So why did you square the 2x?
Okay. When we this thickness is my delta x. And then I need this whole thing over here, all of this. So it's pi, that's this height. And to find the area of this, we need to go pi r squared. And so that's why I had to square this. So it's 2 to the 4th.
So then it's, never mind.
Okay? Now, I have this one. And I think I'm just going to leave that b a minute and redo it and go the other direction and ask you if you can visualize what the differences of these two happen to be. Like we're going to go this way again, and we'll go like this again, like that, and here. Same units over here. This is a line, and it's y equals 2x, and this one here is y equals x squared. And I'm going to go around the y-axis. In other words, I'm going to go this way. Now, I want you to visualize kind of the differences. How does this thing look differently than this one? I'll first do the derivative part. Now, you notice in this case, this is 0. This up here is 4. Up here, the top is 4. So I'm going to go from 0 to 4. And this is delta y. So that's a dy. Okay, now, this one is now on the outside. Okay, so this is going to be x squared squared, pi out here. And I'm going to subtract from it the one on the inside. Oopsie, that's not x squared. Oopsie, just a second. We have to have y's in here, not x's.
So the square root of y.
So this implies that the square root of y equals x, and this is the x distance. So this is going to be the square root of y squared.
Pi.
Pi over here.
Okay.
Got it? Good?
Okay.
And then we're going to subtract this inside part here. So that's from this one this way. And that's going to be equal to
Y over 2.
x equals y over 2. And so this is going to be y over 2 squared. Okay? Now, that's just setting it up. And you can handle the rest. Okay, now, when I did this one and this one, what do you notice about the inside of this one versus the inside of this one?
Is that
Pardon?
The inside of that one flat.
The inside of this one is flat, and the inside of this one is curved. Got that? Anybody have another observation? What about the height of this one versus the height of this one?
That one's taller.
This one's taller. We have rotation. This one's only 2 out here, and this one is 4 up this way. Okay? Questions on that? So we okay. Those of you who have to leave, let me just dig them out, and I'll hand the rest out at 3 o'clock, and we'll start walking back. Who else is leaving? Those who have, okay, just come up here and I'll.
And Jason too.
You're right there.
You're going to?
We're leaving at 3.
Oh, you're leaving at 3.
Yes.
Oh, those who have to leave at 3, pick their stuff up too.
What parking lot? Everything that.
Yes, I'm going to teach you. You bet.
Oh, you are? That's still.
Yeah.
I want my tag.
Too bad. They're With the key done.
Oh,
Not now.
fine.
It's not done.
Let's
Think a little.
Nah, it's too much work. No.
Okay. Okay. One more to take a look at that I'd like to do with you that maybe you can understand a little bit better. Let's take a situation like this. We'll take a circle like this, like we had a while ago. Let's use the same one we had. Y equals the square root of x, 25 minus x squared. And what we're going to do is, there's a point over here, which is 3 comma 4. See that? Any questions about that? Well, I'm just going to put a line over here like this, and that line is going to be y equals 4. I have to have your attention on this, otherwise you're going to be totally lost in what I'm doing. Okay? It's almost like a tire in a sense. This is the outside of the tire, which is rounded. The bottom side is going to be flat. And the middle is going to be gone. And I'm going to go in terms of going around that axis. And I'm going to try to find the volume of this thing, that part there, going all the way around. Okay? This point right here is what? 3. And this is 3, 4. Okay? Now, watch what I'm going to do. I'm going to rotate this all the way around, so this is going to be like a tire all the way around with a flat inside and a curved outside. Okay? Now, to do this, I'm going to do these little Riemann sums like this, only they're going to be discs. And that's going to be a delta x because we're going in this direction. Okay? So, I go like this, and I got a dx over here. Now, I'm going to have to go all the way to the top here, all the way to the top, and what is that equation? That's this one right here.
Yeah.
And I have to square it, right?
Yes.
Okay, so that's going to be 25 minus x squared
Yep.
times pi.
Yep.
You betcha.
Now I'm going to subtract this underneath here.
Now how come, hold on, Mr. Kramer, how come you took the square root out of that?
Here, because I took the square root squared.
Oh, you squared the square root?
I squared the square root, and that's what I got here. Great observation. Okay, now, the next one I'm going to do is this part here. Okay, take that away from it. And so, therefore, I'm going to have to subtract what?
4?
You want, or?
4 pi,
Y?
right? 4 squared, right?
16 pi.
Okay, 4 squared. And I'm going to integrate this from what to what?
Is it the whole thing? So
Why do you
negative 5 to
square it?
5?
From here to here.
Okay, negative 44.
Negative 3 to 3.
Why do you square, Mr. Kramer?
Because this is the bottom disk here, the disk over here, and I'm going from here to this outside, and that's going to be 4 units.
Yeah.
To get the whole area, I need 4 squared.
Okay, so it's like R squared.
That's right, that's R. Yep. Okay, now this goes pretty nice. Notice it's an even function again. So I'm going to go 2 pi, and then I'll go like this from 0 to 3. And look what happens here. 25 minus x squared minus 16 squared dx.
Oh, it's
No,
just
it's
16.
16, you already squared the 4.
Right. Thank you. Okay, so we're going to have a 2 pi. I was thinking here, that's just a 9, right?
Yeah.
Okay, so the antiderivative of 9 is,
9x minus x cubed over 3.
and then I'm going to evaluate that from 0 to 3. Let's just do it. It's kind of easy. 2 pi,
minus
yep, 27 minus
9.
27 over 3. Okay, and so Derek already said 9. And so this is going to be
36 pi.
36 pi is my, okay, and that's going to be units cubed. Because this is the thickness, this is the height squared, and so you have volume. Yes?
Do you square both parts because it's like one radius minus the other radius?
Did you hear what she said on that one? I was working on it a little bit this morning. Yes, you square this radius and that one. Don't put them together and then square them. You have to do them separately, okay? Because you're going to figure out the volume of the outside first, and then you're subtracting it, the inside, but then the calculus says, hey, if you can simplify in the inside, go ahead and do it.
Right.
Okay? So I think this is kind of cool stuff. And so, here is the assignment that I have. I don't have it online. Right there. Now, also online, I do have your review. Did anybody check it? The exam review?
No.
Okay. That's up there. Now, because most of you, I had this up here because I wanted James to do his. James did problem 3, 1C, differently than I did. Now, Paula, do you want to leave? Is Ken's in here too? Yeah, you just take your stuff along. Could you pop in for just a moment, mostly about your neat paper? I wanted to talk to you. That I really like. Okay, and yeah, 3:15 is fine. Okay, most of you had trouble with this, but James did, and I was going to have him do it here, where I do it a little differently than he did. His technique was he used this as his u and then squared it. And it turns out about the same kind of thing. But anyway, we have done one like this before, and you saw probably that you needed the u to be this, which is underneath here, like this, okay? And so, get your du, I needed a 2, so I have a half here. And now this here, this here is my du. Okay? Any questions about that? And this is my u, that's here. But now, I still got stuck with the x, and this is where you were having trouble. But I could solve for x here, and I find x is equal to u minus 1 over 2. Okay? So, instead of writing this x, I put u minus 1 over 2. See? And then it flows just as nice as can be. Okay? Now, this is the one that gave some of you difficulty. Now, when I picked this question up, I thought it was going to come out differently because this was run right out of your book. And I thought it was a little different. I thought this was missing. And it wasn't. I thought it was be a 1, and it was gone pretty quickly. But after I started working with it, I said, okay, this is good too. Okay? Now, I don't think you have any trouble here, but we'll go there. But does anybody have any trouble up here? See how that works? Nice little technique. Okay. Then simplifying this, see, I took this 2 and put it out here and made it a 4. 2 and 2, 4 out here. And 1 to 9. Anybody trouble with the integration 1 to 9? Okay? So that's how that one goes. Then, the test. You could get as high as 112 points because for many of you did all of them, and therefore I gave 4 points for each of those that were correct. If you did it correctly, then you got 4. The integration, or excuse me, the substitution ones, they're worth about 12 points apiece, and the other ones are 14 apiece. So you get like an idea of how much is what. Okay? So,
I'm scared.
Oh, Mr. Gamer, what assignment was due today?
6-2.
Like 23, 24, 27, 30.
I'm 380.
Okay, and I have a bunch of zeros, and I've crammed a few people, so I get some stuff done. Let's see, do I have anybody here that I need to talk to specifically? Because I'm going to give you the last test, but I still can't give you the one before. Because there's still a couple people that haven't taken it. Let's see here. Tanner?
It's a miracle.
Just do it later. Okay, Shannon, oh, you went over there. I did have these in somewhat order.
Yeah, I got them. I wrote all that. Ooh. Oh, I didn't think you had to write that. I just knew DX.
I know, I got prints off that.
Yeah, I saw your name.
Okay, sorry I didn't label. That's why I got Dr. It's all DX. It's labeled. All DT.
Okay,
DX. DX.
you got this assignment down? I'll flip this up pretty soon when I finish.